Hi, I'm Tina from Prep 101. In this video, I'm going to review basic permutations. These will come up in Unit 1 and then again in Unit 2 for probability, so it's very important that you learn them really thoroughly. Okay, let's get started. Okay, so this is an introduction to permutations. So first of all, if we have a permutation in a line, let's say we have maybe 4 different people. So if we want to arrange 4 people in a line, it would be n factorial, in this case 4 factorial. The first spot we'd have 4 choices of people, and then once we use someone up we have 3 choices left, and then 2 choices, and then 1 choice. And that's read 4 factorial, which is 4 with an exclamation mark. And so the permutations for n objects in a line is n factorial. So if we have 10 people in a line, it would be 10 factorial. Now, the number of circular permutations, so if we're looking at a circle, is not the same. It's not n factorial, it's n minus 1 factorial. And that's because if we're looking at a circle, we don't have a distinct start and finish like we do in a line. This is the start of our line, the first person, and this is the end of the line, the last person. But in a circle, it just kind of wraps around. So we have to start the circle with somebody. So if we have 4 people, again, in a circle, we start the circle. Let's say I start the circle, there's Tina. Then that means there are 3 people left to arrange around the circle. And so we get 3 factorial. So in general, it's n minus 1 factorial. So if you had 10 people in a circle, then the number of arrangements in a circle of 10 people would be 9 factorial. So let's do some examples here. So example 1, find the number of ways to arrange 6 different people in a line. So this would be 6 factorial. And you can just leave it like that. And on the exam, the answer would be just 6 factorial. Sometimes they'll make you work it out. So something like 4 factorial, they might make you do it. So we'll talk about how to do that in a second. And here, if we have the number of ways to arrange 6 different people in a circle, this would be 6 minus 1, or 5 factorial. Now, if we have the number of arrangements of the letters of Sophie, this is 6 different letters. We'll talk about repeating letters later in prep, but for 6 different letters, it's the same thing as if we had 6 different people. So it would still be 6 factorial. So a little summary here of permutations of what you need to know. There are a couple of additional formulas that you need to know. So the first is n objects arranged in a line is what we just talked about, n factorial. So if we had something like 4 factorial, we said that's 4 times 3 times 2 times 1. So if we worked that out, 4 times 3 would be 12, times 2 would be 24. And so that would be 24 different ways to arrange 4 people in a line. If we have n objects arranged in a circle, then that you want to learn is n minus 1 factorial. Now there are 2 other cases that we'll talk about in this section. If we want to arrange only some of the objects, so we say sum k of n objects. So some of the objects. If we want to arrange some of them in a line, then the formula is n factorial over n minus k factorial. This is not the choose formula, so don't mix it up with the choose formula, which we'll talk about later. But the choose has a k factorial on the bottom. This formula chooses and arranges the objects for you. So if they say arrange 3 out of 10 photographs, then we would use this formula. 3 would be the k, and 10 would be the n. Now if we're looking at a circle, arranging some k of n objects in a circle, then all we do is add a 1 over k out in front. And the rest is the same, n factorial over n minus k factorial. So now we're going to talk about some different words here. We're going to talk about computer. So find the number of permutations of the letters of computer. And then we're going to do various instances here. So part A is begin with a C. So first of all, computer has 8 different letters. So beginning with the C means we have to put the C first. There's not a line under the C because we're not moving it. We have to put it there and just leave it there. So there are 7 letters that are free to move about and switch with each other, right? This can go here, this can go here, etc. So that means it's 7 factorial. The C is just fixed out in front, and there's one way to put it there, and timesing by 1 won't change our answer. Have all the vowels together. So vowels in computer are O, U, and E.
If they're all together, they can move down the row as long as they're stuck in one spot together. So I draw a line under them and just one line for all three. So of computer, there were 8 letters. So take away 3, that's 5 left. So how many units or how many things are we arranging? Well, we have 1, 2, 3, 4, 5, 6 things to arrange, 6 factorial. Now, is that our final answer? Well, it's not going to be our final answer because this O, U, and E can be in their own group and arrange themselves in different ways. So we can rearrange, put the E first, put the E in the middle, etc. And so there's 3 factorial ways to arrange the vowels in their own group. So our answer would either be 6 factorial, 3 factorial, or you can reverse the order, 3 factorial, 6 factorial. Either one is fine. And the last one is a little bit tricky, the number of ways to have the E and R apart. Well, the question is, how do we get them apart? Do we put the C between them? Do we put the P and the C between them? Do we put the T between them? There's too many instances to look at. So what we say is the number of ways for the E and R to be apart is the total ways to arrange computer minus the number of ways that the E and R are together. And we'll use this method a lot for people being arranged in circles where people are apart, things like that. So the total ways to arrange computer is 8 different letters, so 8 factorial. Minus, now let's draw out down here the number of ways the E and R are together. So draw the ER in one spot and draw the rest of it out and see if you can figure out what you would get here. So hit pause and see if you can figure it out. So with ER together, we have 6 other letters. So what are we arranging total here? We have 1, 2, 3, 4, 5, 6, 7 things to arrange, or 7 units. And then don't forget, that's not your final answer. ER could be ER or RE. And so that would be our final answer. And there's nothing you can do to it. They're too large to work out, so you just leave it alone. Okay, so number 5 here, we've got find the number of circular arrangements of 8 people. So I always just write down, okay, how many do we have? And is it in a line or is it a circle? So 8 people in a circle. If Grant, Jason, and Daniel, 3 of the 8 people must sit together. So remember, in a circle, somebody has to start the circle. And when we have a restriction, people being together, then they start our circle. So Grant, Jason, and Daniel go there, and I put an X because they don't count in the arrangement. So of the 8 people, we have 5 who are really being arranged around the circle. So that's a 5 factorial. Now, that's not our final answer. Why not? Well, because Grant, Jason, and Daniel can arrange themselves in their own little group. They can still stay together, but they can be arranged as Grant in the middle, Grant at the end, Daniel in the middle, etc. So that's 3 factorial ways to arrange Grant, Jason, and Daniel together in a circle, okay, with 8 people. And how would your answer change if Jason must be in the center and the 3 boards are together? So if Jason is fixed, then Grant and Daniel still have these 5 others, but Grant and Daniel can switch with each other. So how would your answer be different here? Well, we'd have the 5 factorial for the other people, and then instead of a 3 factorial, we would just have a 2 factorial for Grant and Daniel to switch spots. Jason is fixed in the middle. Okay, number 6. In how many ways can Whitney arrange some 6 out of 10 books on a shelf in a row? So this is sum K of n objects in a line. So K is how many you want to arrange, and n is always the larger number, how many you have. So remember, the formula for sum K of n objects is n factorial over n minus k factorial. So it would be 10 factorial over 10 minus 6 factorial. And we would just leave that as 10 factorial over 4 factorial. It's too large to work out in your head, and you're not allowed a calculator, so that's how we leave the answer. Okay, a couple more here. In how many ways can 8 girls be arranged in a circle so that Rosemary and Elizabeth, 2 of the 8 girls, are not across? So again, just like not together, not across becomes complicated because where are they if they're not across? There's too many different ways, too many things to look at. So we do the number of ways they are not across would be what? What do you think here? So we take the total ways to arrange 8 girls in a circle, 8 in a circle, and we take away the number of ways that Rosemary and Elizabeth are across. So total ways for 8 people in a circle, remember, is not 8 factorial, it's 7 factorial. Now, tricky part, if Rosemary and Elizabeth are across from one another, let's think about this for a second. If they are across from each other, does it matter if I put Elizabeth here and Rosemary here? Would it be a different arrangement? Well, no, they'd still be across from each other. So you don't get a 2 factorial for people being across in circles. You also don't get a 2 factorial for people alternating in circles. The only time you get the 2 factorial is when Rosemary and Elizabeth are sitting beside each other, so together. Okay, so make a note, no 2 factorial for across or for alternate in circles. And those are very common on the exams. Okay, so here, if we place Rosemary here, then Elizabeth has to go there. And so we've taken up 2 of the 8 people. So we have 1, 2, 3, 4, 5, 6 left. And our answer is 7 factorial minus 6 factorial. And the last one here, in how many ways can Adam arrange 5 of his 20 trophies in a circle? So we're talking about in a circle, 5 of 20. So this is, remember, k of n objects, but in a circle. So our formula is 1 over k, n factorial over n minus k factorial. Whenever we're arranging some of them in a line would be n factorial over n minus k factorial, and in a circle we add the 1 over k out in front. So we'd have 1 over 5, 20 factorial over 20 minus 5 factorial. So 20 factorial over 15 factorial with 1 over 5 out in front. So we'll be doing lots of examples at prep with people together, people apart, people alternating, all different scenarios where we'll talk about arrangements and permutations.
I hope you found this video helpful. If so, see more videos in this playlist. Don't forget to join the Facebook Study Hub. Use the link in the video description box. Also, I hope to see you at my prep sessions, where I'll show you lots of tricks on how to ace your exam. I'll go through every problem that you need to solve, and you'll solve them with confidence by the end of my prep sessions. Many of our prep sessions are free, so go to prep101.com now for more details and to sign up. I hope to see you soon. Take care. Bye.